Today we talk about aliases, and today we talk about a certain kind of problem that can arise and functions that mutate lists that can lead to bugs that are so difficult sometimes to find. I found myself in a situation like this before with a student a few years back. He brought me some code. I read the code. The logic looked perfect. I believed that it was, but it didn't do what we wanted it to do. Do it didn't do what we thought it should do based on the code that we saw in front of us. Um, and I actually reached the point where I believe that Python itself must be flawed. But after, I think it was a couple of weeks, I finally realized how all this worked, and it had to do with aliases of mutable data types, like lists. We know that lists are mutable. We've seen examples of how it is that we can mutate lists, like with the append function or the pop function. But I didn't really understand how that worked. So when I read the code, I didn't understand really what it did. So even though it seemed perfect, it wasn't perfect, and I couldn't debug it, and it was a mess. But now I think that I do understand this. I know that I understand it. So I wish to make sure that you don't fall into that black pit of despair into which I fell. Okay. So aliases, what is that? An alias is simply when you have multiple names for an object. Okay, so here we go. A, 1, 2, 3. So that's a list that contains the elements 1 and 2 and 3. There it is, A. Now, I can give that list another name if I like. B, let's say. So I've said that B will have the same value as A, and if I look at B, then sure enough, there it is. It contains the elements 1 and 2 and 3. Now, here's what happens when you mutate an object, okay? Here's what happens to the name of the object and the alias. So let us add a 4 to the list A. Okay, so there's A, it's 1, 2, 3, 4. Now let us consider what B will say. Will B simply be 1, 2, and 3 like it was initially? The answer is no. A and B name the same list. That list was changed, so B now names a changed list. It's very much like, I don't know, Clark Kent and Superman. They're the same person, the same man. So let us say that, I don't know, by some tragic accident, Clark Kent loses his leg. Well, that means that Superman now only has one leg, right? Because they're really one and the same person. A and B are one and the same list. So when I make a change to A, that change, of course, is also reflected in B. So there it is, 1 and 2 and 3, 4. 1, 2, 3, and 4. So that's what we mean by alias. You have an alias when you have multiple names of an object. And then when you have a mutable data type like a list, if you use one of the names to mutate the list, then when you consider that list with the other name, when you access it with the other name, it will be that same changed list. Now, why do we have to talk about this? Why do we have to worry about it? Well, if you're not clear about this, then you can write code that would seem good, but doesn't do in the end what it is that you want it to do. Let's write some functions. I'll show you an example where this happens. So we'll write a function called the number of odds, which will take a list of numbers L and return the number of odds. We'll also write a function called number of evens, which will take a list L and then return the number of evens in that list. So we'll, of course, need a count variable in each of these that will count the number of instances of whatever it is, either evens or odds. And then let me show you one way that you might think to do this, right? It will initially look good. It'll seem right. And I've seen students do it this way. You know the pop function, right? The pop function returns the final element of a list, right? So someone might think, okay, so I'll just simply pop up the final element off, right? And then I'll pop again the final element off, and pop the final element off, right? And that way that I'll work my way all the way through the list and consider all the elements and just count the ones that are odd, right? So here we go. So let me continue to pop elements off until such time as L is the empty list. I mean, that's eventually what you get when you pop every element off of a list. So while L is not equal to the empty list, oops, let me get this right. So while L is not the empty list, let's pop an item off. Okay, so that will be L.pop. That'll be the final element off the list. So if item, we wish to know whether we get a remainder of 1 when we divide by 2. That's what odds do for us, right? Give us a remainder of 1 when we divide by 2. Then count will be increased by 1. and then we'll return finally the value of count, right? And it would seem that this will work, and I think that it actually will, right? Because you'll pop an element off, which removes the item from the list and returns it. And then if it's odd, we increase count by one, and we continue on until such time as L is the empty list, and then we just return the value of count. Okay? So actually, I tell you what, I'm going to go ahead and test num odds. So how about num odds in just one, two, three? Should be two, right? Yeah, well, I think that it works. And I tell you what, I'm just going to copy paste. We have to make one very small change to count the number of evens. Call that num evens. So here we go. Let me make sure the indentation is right. There we go. And the only change that we have to make is, well, evens leave a remainder of 0. We divide by 2. Right, so let me run the code again. And then I'll test num evens. And then about 1 and 2 and 3 again. That should be 1 in this case. Yeah, so I know that so it seems that my functions work, right? Now here is the issue. Okay, here is the issue. Let me just show you an example of it. So let's say that we had a function, excuse me, that we had a variable. The variable will be L. It will be the list that contains the elements 1 and 2 and 3. And then let's run num odds on L. There we go. That once again should be 2. Okay, so it is, so that's correct. And then let's immediately run num evens on L. And it's 0. And how could that possibly be? Right? Because we just checked num evens a moment ago. We did it with the list 1, 2, 3, and it returned 1. I mean, why is it now broken? Perhaps you can understand why this would seem so deeply mysterious, right? We tested num odds, and then we tested num evens, and they were both correct. But now when we run one and then immediately after the other, the second one seems broken. How could the execution of one function break another function? Well, the answer is this. It didn't break the function. The function still did precisely what it was told to do. But what the numodds did is it mutated L. Let's take a look at L. Oh, L's the empty list. And how did this happen? Okay, how did this happen? Well, it was a mutator. Okay, it was a mutator. The value of the list that was actually sent to the function, even though it was given its own name within the function, was mutated, right? And that mutation then appears even outside the function. So be very, very careful with this. Be very, very careful when you write a function that mutates, and be aware of the built-in Python functions like pop and append and so on that actually mutate a list. You might not wish that that list will be mutated, but you might do it anyway, okay? And that means that it might well turn out, like in this case, that when you test that function in isolation, it seems to work perfectly. But then when you run that function and then another function, that other function appears broken. And the reason why it will appear broken is that your first function actually mutated the list. So the list that you thought you sent to the second function was not the list that you sent to the second function. So my plea to you here is this, is you must be careful when you write functions that use mutators. Be very aware that you have done this, and think carefully about what it is that happens to the list that gets sent to the function.